Hello everyone, I'm Roxanne, CEO and co-founder of AnyShift. I'm sorry in advance for my French accent. At AnyShift we are building some AI SREs based on a deep knowledge graph of the infrastructure. And today I'm going to showcase an example of why LLMs, GitHub Copilot, Cursor, break sometimes the infrastructure. So maybe first of all, everyone has answered practically yes to say that you're using AI for code generation, but who is used to actually create some infrastructure as code in their day-to-day? Not that many people. Okay, I will try to make it as simple as I can. I like to try to explain some concepts. If you have some question. Yeah.
Not too close to me because it's disturbed. No, it's like a compression.
Thank you. Thanks. Okay. So maybe do like up and downs, thank you, when it's not working. Okay, so let's see why LLMs for your infrastructure are not perfect and the inherent limitation that they have in their day-to-day. And today I want to speak and highlight the importance of context when it comes to code generation. And in this case, for infrastructure. What I did here was actually asking a simple task to different type of AI and code generation, which is kind of a task that a DevOps or an SRE in your team would do. Here, what I'm just asking would be like in Terraform, which is an infrastructure as code pipeline, to create a VPC peering connection. So basically, connect two VPC that would be normally yours, like of your company, and of another vendor, for instance. And so the first thing that I could get as an answer, and here I'm illustrating for a developer, so a software engineer, would be that making a VPC peering connection is actually connecting two VPC together. And in AWS or GCP, you would get the IDs of those VPCs. And so, sorry. Better like that? Yes? Okay, thank you. And so, like an easy thing to do would be, is it better? Perfect, thanks. Would be to copy-paste the IDs to make the connection. Bad thing is that when you're like an SRE or a DevOps in your team, it's actually a bad practice to do so. If you keep those hard-coded values, you may break your pipeline next time you're actually applying a change in production. So you should use dynamic references. Those dynamic references are here, kind of a standard when you're a dev. And that would be kind of a good practice that GitHub Copilot would follow. I'm going to make those dynamic references. The thing is, because I'm not referencing to the ID of my VPCs anymore, I'm missing a reference to my VPC. And so what Copilot would do is to actually try to make sense of this reference and continue code generation by defining a new VPC. Issue is, it's not the correct one. This is just hallucination. Because Copilot doesn't have the references and the dependencies in context. So I guess the big question that everyone is thinking of is, can Cursor do it? Because Cursor have all those dependencies, or like Windsurf, etc., in hand. This is, just for reference, how the right code should look like. I have my dynamic references with my two different VPCs. And in another repository, I actually have a pointer to a data source, which is a reference to my already existing VPC in my cloud. But now let's go back to my developer and to the IDs that he has in hand. Those IDs that reference to your existing machines or like configuration in your cloud is actually only available in your cloud. when you try to make a link between those values and like a reference of a name in another repository, something that Cursor would try to do, it's actually impossible, completely impossible to make the link, because there is no direct connection between this ID and this reference. And because of that, tools such as Cursor, Windsurf, etc., because they don't have access to your IDs or ARNs in your different cloud providers, cannot generate the right infrastructure as code. They can do something which is 80-20, but it will never be perfect. I just want to illustrate very quickly how this look like. A very basic example. I'm going to use Cursor, and I'm going to actually zoom. And I'm just going to list my insecure. Cursor, very basic. IAM user, sorry. I just want to showcase here that Cursor is capable of reading through all my repositories. And actually, it's even not responding well. So you can see that when I'm asking Cursor to list some IAM users, it's kind of failing to do so. Expected answer would be like to list IAM users in my different repositories. What I wanted to illustrate would be that actually, when I'm looking at this specific repo, I have a list of all my IAM users, Stefan Jordan, Roxane Fischer, but when I go on AWS, which is here, if I have a list of all my IAM users, some of them are not defined in Cursor because they were manually defined in your console. Some things are sometimes not properly defined in your code and only living in your cloud. And because of that, I have here, for instance, a temporary user that I have ClickOps. I've just created it on the console. And so Cursor would be strictly incapable, sorry, to generate it with its right policy, which is attached to it, because it's missing the context. And so if I go back to the importance of context when it comes to code generation applied to infrastructure, the last part of this talk is about the fact that your infrastructure is a graph. And it should be understood and taken as is. It's a graph and it's complex. This is kind of a representation, a snapshot of how it is built, with all the different nodes that interact. A node being like compute instance and linked. So this would be, for instance, like an EC2 instance, linked to an IAM, linked to another like EC2 instance. So everything that you have like in your different cloud providers. It's way more complex than that. You can have like multiple accounts, multiple clouds, 10,000 of resources. So actually, your infrastructure looks more like that than something else. I just want to finish this talk by speaking about how to solve those issues. Two main paths of actually solution and how to build that. The first one is to build a graph DB. This is what we do at AnyShift. We build this knowledge graph of the infrastructure where we are actually going to map all the different cloud resources, Kubernetes one, nodes from your code base to make sense out of all those relationships for code generation. This takes a lot of time. You need to process all those different live data coming from different resources. And so it's time heavy and hard to maintain to do internally. A second option, which is already great, is to use MCP servers. I guess who knows and use MCP server in this room? Many of you. So, for instance, you have like the AWS one, which is great. You have also like the Kubernetes one, which has just been released. They can already give you the live context about your infrastructure, but they miss the dependencies between those cross vendors. If you want to understand that you have like an EKS cluster and within Cube, that is in AWS, you're missing the fact that you have multiple instances from multiple sources that are interacting. And I think we won't have time for this part, but if you have any question, thank you so much, and thanks. Thanks for listening. Questions? Yeah. What is an shift? So we label ourselves as an AI SRE. So we have like a chatbot where you can ask any question about your infrastructure. So in terms of cost, compliance, infrastructure management, why can't I connect to my RDS? What is happening? So those kind of questions. We do also like code generation. So imagine, so our chatbot, you're asking a question about, do I have something which is not properly defined in my code? I just got an incident, what should I do? And it will also like create a pull request out of this analysis and then remediation. So really like, you can see yourself as kind of a devin of your infrastructure. Yeah.
Do you have an MCP server that backs into the graph database that you make?
Yeah. So you can use our MCP server. So it's actually mapping our knowledge graph that reconciles different sources of data. And so when you call it in cursor, you would get like the proper like code generation. Thank you.